All right, welcome back. So today we are going to be furthering our discussion of all about factoring. But this is really the heart of our quadratics, is we're going to learn how to factor these quadratic equations. This is x squared plus bx plus c. We're going to be talking about how to factor these quadratic expressions when the leading coefficient, that a value, the coefficient of x squared, is going to be 1. Then later in the week, we're going to be talking about how to factor when that leading coefficient, we call that the a value, is not 1. But today, let's talk about how to factor these quadratic expressions. So please have out your guided notes for 7.3, and let's begin. So when factoring x squared plus bx plus c, we have a couple different instances. If the c value is positive, so notice, talking about the c value, that what we call that the constant term, it's not going to have a variable. If the c value is positive and the b value is positive, then both factors are positive. And we're going to be going through an example right now with this. We will come back to the negative aspect in just a moment. So let's say we want to factor x squared plus 7x plus 10, and we're going to check our answer. What we want to find is we need factors of 10. So we need factors of 10. 10 again is our c value that will add up to the b value of 7. So we can list out factors of 10. So factors of 10 could be 1 and 10. The sum of those is 11. We have factors of 2 and 5. The sum of those is 7. So what we're going to do is we can write it as x plus 2 and x plus 5. The 2 came from one of the factors, and the 5 came from the other factor of 10. And we can check this by foiling it out, and we're going to end up with the expression that we started with. Now, there is another way to go about it, and we're going to be learning all different types of ways, and you might even go online to try and find a different way, and it all matters that we get to the same end result, right? If we're all going to the same party, we got to get to the same party. We can walk there, we can jog there, we can scooter there, right? We can skateboard there. Doesn't matter, so long as we all end up in the same destination. I'm going to show you a way that I use for all instances, and this is just my preferred way. You can use whichever method you want to. We're going to be practicing a lot with these. This is going to be my way, like Frank Sinatra. So we have x squared plus 7x plus 10. What I do is I'm going to multiply the a and the c value together, and that gives us 10. Now, we're going to identify factors of 10 that will add up to 7. Well, we already found them previously. It's 2 and 5. So what I do is I go back and I rewrite the expression. We're going to have x squared plus 2x plus 5x plus 10. We just substituted in another way to write 7x. 2x plus 5x is indeed 7x. And now I'm going to factor by grouping. If I group these first two terms together, and then the second, or the third and fourth terms together, I should say, now we're going to factor anything out that we can. Well, in this first set, x squared plus 2x, I can factor out x. When we do that, we're left with x plus 2. On the right-hand side, we have 5x plus 10. We can factor out positive 5. And we're left with x plus 2. So now we have the same exact set of parentheses, so we can factor those out just like we did previously coming into today's lesson. And now we're left with x plus 5, which is, again, the exact same answer as we have before. So I'm going to be using this process for every example that we go through. Again, you can use whichever method you want. Let's go on to another example. We should still be on the front side of our guided notes. We're going to talk about this bottom part. If we are talking when C is positive and B is negative, then both of those factors are going to be negative. So let's say we have x squared minus 9x plus 18. Notice our C value is positive, our B value is negative. So we need to find factors of 18 that add up to negative 9. Well, we can list out our factors. Negative 1 and negative 18 does not add up. Negative 2 and negative 9 does not add up. Negative 3 and negative 6 do add up though. So we can rewrite it as x minus 3 and x minus 6. Again, the x minus 3 came from one of the factors, and then minus 6 came from the other. If we were to use the method that I like to use, we have x squared minus 9x plus 18. Again, I'm going to multiply that a term, the coefficient, with our c term, and we get 18. We have to think of factors that multiply to 18 but give us negative 9, and luckily enough for this example, we were already given it. So we're going to rewrite it. X squared minus 3x minus 6x plus 18. We can break these apart. Notice how I'm including the signs in that third term. If we pull out x, we are left with x minus 3. Our goal is to have these matching. So in order for us to get x minus 3, we have to pull out negative 6. We end up with x minus 3. And now we can factor out x minus 3. And we're left with x minus 6, which again is the same as we did before. So it's just another way for us to factor. We can always check our work by foiling it out and making sure that our factors are indeed true. So again, we are working backwards now. Instead of foiling, we're bringing it backwards, getting into a position to foil. With this, please work on problems 1 through 5 in the guided notes and resume when you're ready to move forward. All right, so we should now be on the back side of our guided notes, and we are going to be talking about 2 more instances, one and then another. If we have C is negative and B is positive, then the larger factor must be positive. And let's talk about what that means. Let's go through an example. Let's say we have x squared plus 8x minus 20. You're going to notice that our C value of negative 20 is negative, and our B value of positive 8x is, well, positive. So we have to list out factors of negative 20 that add up to 8. So since we have a negative number, we're normally going to include the same numbers but different signs within the factors. So we have negative 1 and 20, negative 2 and 10. That also that works. Those are going to be our factors. We have negative 4 and 5. But notice here that since we already know that B is positive, you're going to see that the larger factors are positive. 20 is larger than negative 1. 10 is larger than negative 2. 5 is larger than negative 4, pardon me. And now we take them and we substitute it into our FOIL, our set of binomials. So we have negative 2 and then positive 10. That looks bad with green and purple, I'm sorry. But now let's go over on the right-hand side and let's use the process that I like to use. I'm going to write it out again, x squared plus 8x minus 20. I'm going to multiply the a term with our c term. Remember, our a term right now is 1. It's our leading coefficient. We end up with negative 20. We need factors of negative 20 that add up to positive 8. Well, luckily enough, we already figured it out, so we can just substitute it in. We have x squared plus 10x minus 2x minus 20. Our goal is to group and then have the same parentheses inside. So if we're looking at this first set, we have x squared plus 10x. We can factor out an x. and we're left with x plus 10. Our goal is to get x plus 10 in the second set. So in order for us to do that, we have to factor out -2. In doing so, we get x plus 10. Now that we have the same set of parentheses, we can factor that out. We have x plus 10 times x minus 2. And although it's a flip-flopped order, it's the same exact answer. And remember, we can always check this by FOILing it out and making sure that we ended up back where we started. One more example. So this time, if we're talking about C being negative and B is negative, then the larger factor is going to be negative. So let's go through an example to show what that means. Let's say we have x squared minus 3x minus 28. You're going to see that our constant term, the term without a variable, is negative. And we have that middle term, its coefficient is negative. It's -3, which means the larger factor of whatever we're trying to find, that is going to be negative. So let's list out those factors. We need those factors of -28 that add up to -3. But remember, the larger factors are going to be negative. So we have 1 and -28, that doesn't work. 2 and -14, that doesn't work. 4 and -7, that does work. So we're going to replace the 4 and -7 within our set of binomials. We have 4 plus 4, -7 as a factor, and -7 within the FOILing process. Now, if we were to do, pardon me, the way that I like to do it, again, we're going to multiply that a term, right now it's 1, with -28. We want to think of factors of -28 that add up to +3. Sorry, this should be -3. That is a huge typo. Also here. Whoops. Sorry, kiddos. Technology, eh? So we have to know that the larger term is going to be negative. Luckily for us, we already calculated it's 4 and -7. We end up with x squared minus 7x. Let me do that in green to be consistent. Minus 7x plus 4x minus 28. Again, we're going to group them together, include those signs between the second and third term to see what we can factor out. Well, we can pull out x in that first set. We end up with x minus 7. So in order for us to factor the other set, we want to end up with x minus 7. To do that, we can pull out +4. We end up with x minus 7. Notice we have the same set of parentheses, so we can factor that out. We get x minus 7 times x plus 4, which is, again, the same as we have over on the left-hand side. It's just a flip-flopped order, but that's totally okay. Remember, we can always check by sending it all out and making sure that we ended up where we started. Fantastic job with this, kiddos. This is going to be a process that's going to take a while. So long as we're trying our best with it, the more practice we have, the better off we are going to be. Keep on working hard. If you have any questions, please do not hesitate to let me know, and I'll talk to you all soon.